What is up, happy peoples? Today we're going to talk about binary trees and tree traversal. Such a question is, how can trees represent arithmetic operations? So want to specifically look at binary trees once we get to that point, and talk about how those binary trees can be used to represent arithmetic operations. All right. So first of all, we want to talk about what a rooted tree is, and so I want to look at this GeoGebra um, example that we have here, and we want to talk about rooted trees. So looking here, once it loads, we see that we have this particular tree. Now, while we have this tree, I want to first of all talk about a rooted tree. A rooted tree has a specific root that we start with, a specific place that we deal with when we have our particular tree, and it kind of serves as the beginning of everything. So there's a couple of different ways we can look at this. First of all, one thing I want to bring about is that a tree can have many different roots. So depending on what the scenario is, what the setup is, we will talk about whatever that root is. So for example, if I made A my root, then A has one direct descendant, which will be E, and then E in itself would have several descendants, which would be B, C, G, and F. So all four of these would be on the same level as well. And then C would have a one descendant, one child, if you will, who is D. All right. However, if we decided to change around what the root was, for example, we said let's let E be the root. Now E would have five different children, and C would still have one child. Likewise, what if we decided to let C be the root? Then C would have two children, and then E would subsequently have four children. So again, the point that I want to bring out here is that a tree can have multiple different roots. So depending on what the nature of the problem is, that would determine what the root of that particular tree is. So again, I just want us to understand that when we talk about roots, and also some other things that we talk about here, when we talk about the hierarchy of a tree, we talk about parents and children. So in this case, we will say something like, for example, E is a child of C. Likewise, E is the parent of A, F, G, and B. All right. We can say things like C has two children, E and D. All right. We can say things like E has four children. All right. We can say D has no children. Okay. So again, these are all different things that we can say about uh, rooted trees. If we are given a specific root, these are type of statements that we can make concerning that rooted tree. All right, so going back here, let's put it back on full screen. All right, the root of the tree is the starting point. The tree can have multiple roots depending on the nature of the problem. Trees carry a hierarchical structure. Higher nodes are called parents. That was smart. Parents. And lower nodes are called children. Let's present that again. All right, a binary tree specifically is a tree where each vertex has no more than two children. So the word binary literally means two. So when we talk about a binary tree, we're saying it only has two children. All right. Let's go for that. Click binary trees can be used to represent mathematical operations. So while binary trees are used in other areas such as decision trees and probabilities and things like that, I want to specifically talk about how it's used to represent mathematical operations. So for example, if I say 4 plus 3, what we're going to do is we're going to create a tree, and this particular tree will have the operator as the root. So we would look at having a plus at the root, and then 4 and the 3 would be the children. So we're saying 4 plus 3. All right, that's how we would read that. All right, so that's a binary tree. All right, now actually how we take this information and we kind of work with it, what we do with it, we're going to talk about some different ways different orders, if you will. We're going to talk about um, different ways that we can travel across this tree and read this information. So if I have a computer program and I'm reading this particular syntax, in what order as a computer do I need to read this syntax, and at what order do I need to try to process this information in order for me to come up with my solution of 7? So that's what we want to talk about, even when we talk about tree traversal. And again, as I stated before, if you need to pause, go back, repeat, or what have you, please do what you need to do so that you can have this information. So tree traversal, three different types of tree traversal that we want to talk about: pre-order, in order, and post-order. So if we look at each one of these, the prefix tells us what it is that we're going to be looking at. So when we talk about pre-order, we're talking about before. When we talk about in order, we're talking about in the middle. And when we talk about post-order, we're talking about after. So what are you saying, Sawyer? We're talking about where we're actually going to place the root. So if I were to list these nodes using pre-order notation, I would say something like plus 4, 3. As I was reading that post-order notation, what I would be looking for is, hey, if I have two numbers with the operator directly in front of it, and I'm saying, listen, this is the operation. These are the two inputs that I'm going to be using for that particular operation. So in this case, I'm literally saying, hey, let's add 4 and 3. Likewise, in order, the root comes in the middle, and that's what we're used to, seeing something like 4 plus 3. So we'll look for an operator in between the two values. So 4, boom, plus 3, and we do it like that. Finally, post order, the root will come last. So we have left, right, and then we will have the root that will come last. So 4, 3 plus, and again, in this case, we would look for the root to come last. So let's look at an example of how this would play out in a particular mathematical operation for us. Suppose we have this particular operation here. Let me clear that ink right there, because that's kind of ugly. All right, so we have 5 plus 3 minus quantity 14 divided by 2 plus 1. Now, one thing that I didn't take a lot of time to mention, if we were to do order operations, we would start with parentheses, simplify that, and then what we would do is we would subtract before we would add. So when we determine what the overall root is for our order operations problem, the very last step that we do, which in this case is this addition right here. All right, this addition is the very last step that we do. Okay, let's try this again. This addition is the last step that we do right here. So that plus will be the root of our problem. So depending on what the nature of the problem is, whatever that last step is, that particular operation becomes the roots. All right, and what are we adding? In this case, we're adding all of this plus 1. Now, how do we get all of this? What's the biggest thing that's happening there? We got two parentheses that are being divided by, that are being separated, by a subtraction sign. So we put the subtraction there. And then likewise, within each parentheses, we have a plus sign, we have a division sign. And so we go from there. So here is where we are, and we want to talk about how we use the different notations in order to list these vertices. So what I want to start off with first is pre-order. So I want to start with pre-order. I'm going to put a text box right here. All right, let's go back up right here. So let me type right quick. Okay. Let's do that right there. So right here, we're typing pre-order. So obviously, when we talk about pre-order, we're talking about putting the root first. All right. So we're going to talk about root, left, and then right. So the plus sign would indeed go first because we're looking at that root first. And then we're talking about everything that's on that left side. So everything that's on that left side. And that left side, so basically for each sub-component, we're going to do the same thing. So we're going to look at, okay, what's on the left side over here? We start off with a subtraction sign. So I'm going to put the subtraction sign next. Now, I cannot go directly to the right because I have not finished breaking down what's on this left side right here. So on this left side, top, left, right, but then we got this kind of little sub thing happening here. Top, on this left now becomes top, so we got to go what? Down to this plus. So we got to go down to the plus right here. So we got top left plus, and we're still working off the left side. So everything off the left side. Now, have I finished working left side? No, so because I gotta go. We gotta go down and get all the way as deep down into it as we get, and we get what, 5 space 3. Now I want to stop here because if you recall what I said a couple of minutes ago, when we have pre-order notation, we'll know what to do when we see two numbers that are that have an operator directly in front of it. So while we have all these symbols and everything here, when we actually go to evaluate this, the very first thing that we would do is to add 5 and 3. If we go back to our original problem, adding 5 and 3 would also be the first thing that we would need to do because of the, because of the order of operations. 5 plus 3 would be the first thing that we need to do. All right. So we had top, left, right, but then within this left, we had to go top, left, right, but then within this left, we had to go top, left, right. All right. So we're kind of working back over here. So we had top, left. Now let's go right. So we got plus 5, 3. We're going to put our division sign next and then go top. That was top, left, right. And again, this still follows. The first thing we did was what? Hey, we added 5 and 3. Boom. The next thing we do is we what? We divide 14 and 2. Once we do that, we get these two numbers, plus 5 and 3, divide 14 and 2. So that's going to give us two numbers, all right, separately, in which we're going to, that's going to give us two numbers separately. I'm sorry, let me get this pen working right. Here we go. We're going to have two numbers, and I'm going to put a purple right there. Okay, so we're acting up again. Why does it do that? Okay. Let me see if I can at least get that. Oh boy. Let's get that back up. Click. Okay. So we wanted to finish that, divide 14 and 2, and then at the very end, we're going to put the 1 at the end of that. So the other thing that has to go at the end of that, and I don't know why it does that, but it's not acting right. But there is also a 1 at the end of this for pre-order notation. Likewise, for in order, we will have a particular thing going on. I'm going to pause this recording right now, and I'm just going to type it in, and you'll see it as you all cue the screen back on. All right, so we're back. Again, pre-order notation, we have plus, minus, plus 5, 3, divide 14, 2, 1. And again, the way that we approach something as in this pre-order is that we would actually look at where we have two numbers that's preceded by an operator. So the very first thing that we would do is we would add 5 and 3. All right, we'll get a single number, so we get plus, minus, and then we have an 8 here, divide 14, 2, 1. So then the next place that we would have two numbers preceded by an operator would be the divide 14, 2, and then we get 7. So we have plus, minus, 8, 7, 1. And so we would actually take 8 and subtract 7, and then we'll take that 1 and 1, add those together to get 2, which is the answer for that. Likewise, here's our in order notation, and finally we have our post order notation: 5, 3 plus 14, 2 divide minus 1 plus. All right. So what we want to do is we want to actually look at specifically this post order notation. I want to take some time and deal with that. We have something that's actually called reverse Polish notation. All right, and some old calculators actually use this type of operation to help show what particular operation comes next in a sequence of input. So let's look at that. I'm gonna turn that off. All right, it uses post order notation. Again, the operator comes after the two arguments. So suppose I give us an example of this particular string of operators, numbers, and symbols that's written in post order notation, reverse Polish notation. We understand this is post order. So again, what we're looking for is we're looking for two values that are that have the first two numbers that have an operator behind it. So looking along here, we see that the 8 and the 6 with the minus sign. That's going to be the very first thing that we do. So what this is saying is we need to take 8 minus 6 and 8, 6 negative. All three of these terms here, 8, 6 negative, is saying 8 minus 6, so that equals 2. So when we rewrite it, we have 4, 2. See, we got rid of that because all three of these end up being 2. And then we got times, bring the rest of it down. And so now when we look from left to right, once again, the next thing that we see is we see a 4 and a 2 with a star or with a multiplication. So the next thing we're going to do is multiply 4 times 2 and 4, 2 star. All of that becomes 8. So we get 8, 5, 2, 3 star plus plus. Now when we look again, what we're looking for is the first instance of where we have two numbers that's followed by an operator, and that happens at the 2, 3 star. So 2, 3 star becomes 6. 2, 3 star becomes 6. So we have 8, 5, 6 plus plus. And now we see that we look at 5, 6 plus because again we're looking for two numbers followed by an operator. So we have 5 plus 6, which is 11, and then 8 plus 11 equals 19. All right, this is a reverse Polish notation. You will have a couple of problems where we have to look at that and try to work through reverse Polish notation. So if you have any questions, again, just shoot me an email, and if I'm able to, I will respond likewise. You also have your textbooks that you can use to get this straight. I hope all is well. Again, if you have any other questions, please contact me, and we'll go from there. Thank you all, and have a wonderful day. Bye bye. Oh, we got homework. On page 283, numbers 3 through 6, and also numbers 8 through 16. And this is in preparation for our assessment on tomorrow. That assessment on tomorrow, you will still have until Monday to complete it, but as much as you can get done tomorrow, that'll be awesome. Seeing that it is a Google form, you would need to try to have that completed at one setting. So if you need to go and take it home, what have you, or to look over some other things before you attempt it, please do that. But please make sure you continue to use your time wisely. And yeah, I guess that's it. All right. You all take care. Have a good one. Keep it happy and jump.